doozy. Our objective for today, I can write and graph inverse functions. I can write and graph inverse functions. What's the main idea for today, everyone? The main idea is inverse functions. That is correct. So I'm going to take you back to the first 3 weeks of this school year. Aww. And I remember I said, you know what, guys? I'm not even going to touch the Algebra 2 books until we do a full review of Algebra 1. And we did a full school year review of Algebra 1 in 3 weeks. We covered anywhere from real numbers to expressions to equations, linear equations. From there we went to systems, then we went to quadratics, and I said we'll get to quadratics and cubics now that we get into the course, Algebra 2 course, because we're going to get more into those functions. You guys remember that? Yes, Mr. Q, like it was yesterday. All right, good. And I gave you guys the Ferri model that looked like this, and I said functions, when I first introduced them, I said, are relations that assign exactly one input value for each output value. I'm sorry, one output value for each input. And I gave you guys a relation, which were points like this. And I asked you guys, why is this a function? Because the -2 has an output of 3, and it repeats over here. -2 has the same output, which is 3. That's why it's one exact input value for its output. Okay. Then I gave you guys examples of what they look like written as a rule, and they look like this. Y equals 2x plus 1, y equals x squared plus 1, and y equals x cubed plus 2. And then I said eventually we're going to replace the y's for what? F of x. That became our functions, and that's what we've been working with all year, transformations and such. From there, I gave you guys none examples. I gave you the same relation, except for look at the last point. The last point is -2,7. The first one is -2,3. Why is this not a function? Because when the -2 repeated, it should have been a 3 here, but now it's a what? It's a 7. And so on and so forth. You guys remember these? Oh, yes. All right, on your paper, copy this table, please. You don't have to make the rows. You'll be making the rows after I ask you to copy something on the first row and so on and so on. But title the first column function, the second column name, the third column graph. And I'm going to see, once again, we've been reviewing the different functions that we've covered. I've already done it about 4 times, as I can recall. And I want to see if you remember. So here's the first function. Ready? When you guys were baby algebra 2ers in my class, I gave you this one first. F of x equals x. Copy that one, and then write the name of it. See if you remember the name of that one. And then somebody already made a face like, I don't know. How about a linear? Very good. So you're like, oh yeah, that's exactly what I was thinking. Good. And of course, the graph is a line. That is correct. So at the end, I'm not going to show you the graph right now. You graph whatever you think it looks like, and then at the end, I'm going to show you the graphs as I go through each one. But I want to see how well you remember the names and the graphs by yourself. F of x equals x squared. The name for that one, think about it. F of x equals x squared. That one is known as a quadratic. That is correct. Quadratic. Graph what you think it looks like. Here goes the next one. From there we went to f of x equals x cubed. And what is the name of that one? Yes, it's a cubic function. That is correct. And by now you should know how that looks as a graph. Okay. Go to the next one. The next function I gave you was f of x equals absolute value of x. What is the name of that one? Talk about it never. What is the name of that one? That function. Let's see. Let me pick someone at random. You know what? I'm going to use my randomizer. How about that? Okay? Woo! Let's go. What's the name of that one? How about Maria. What is the obvious thing that you see? Absolute value is correct. And see if you remember what the graph looks like for that one. Here goes the next one. F of x equals 1 over x. That one, a lot of you had a lot of fun with that one, I remember. Yeah. Oh, you're looking at me like, okay. Tell your neighbor the name of that function, please. What is the name of that function? And it starts with a letter R, by the way. Correct answer is rational. Rational. See if you remember what that graph looked like. Next one, f of x equals square root of x. What is the name of that one? Name of that one. How about a radical, or also known as a square root? Yes. Radical function or square root function. See if you remember the graph for that one. And here's the last one that we covered. And you're like, oh yeah, I remember that from the home play, Mr. Q. Good. And that one has a particular name also. Tell your neighbor the name for that one. What is the name for that one? It's also under radicals, but it's known as cube root. Cube root. Did everybody get those right? All right, good. Man, you guys remind me of me and Kinder. All right, here we go. So let me show you the graphs for each of those. So for the first one, it's a linear, and inside the name you see the word line, so it's a straight line, positive, negative, with slope of 0, which is a horizontal. The only one that does not qualify is the one that's up and down, because that makes it undefined, so it's not a function. So the next one, quadratic, it's a what? Parabola. A negative parabola. A stretched parabola. A compressed parabola. Next, cubic. Negative cubic. Stretched cubic. How about stretched vertically? Yeah? Does that look something we've been doing? Yeah. Absolute value. The graph is within the name. You guys see it? Well, there it is. It's a V. A negative absolute value. A stretched absolute value. A compressed. Rational. This is the one you guys had fun with. You guys remember these? Asymptote. Asymptote. With the function right there. And of course, if it's negative, it reflects and so on and so forth. Radical, we always start with 0, 0, 1, 1, 4, 2. However, if it has a negative inside of the radical, it's 0, 0, negative 1, 1, negative 4, 2, and it goes in the opposite direction. How about if it has a negative outside of the radical? It's here, here, and here, and it reflects about the x-axis. Yeah. And of course, last night's home play, cube root. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. There it is. I like this. Look at all the functions. Look at that. Humor, like on a shirt. Bam. No? Yeah? All right, so it's been a fun ride, isn't it? Right? So far, so good? So here are all the functions one more time. Now, what if I told you that out of this list of functions, there's functions in there with their inverse within the list of functions? Let me repeat that again. In this list of functions, some of these functions have their inverse in the same list of those functions. Talk it over to your neighbor, let them know which ones are the ones that have their inverse there. Talk it over to your neighbor, please. Copy and go. All right, I think that was good talking. Let me get someone to help us out. I'm going to use a randomizer. There we go. How about Edgar? Which function do I start with? Close. Help them out. Funny when I start turning there, everybody starts going like, no. Help them out. Aria. Which one do I start with? Cubic function, and that its inverse is what? Which one of those on the list is its inverse? Yeah, you already saw it. Say it. That is correct. Cube root. These are known as inverses. All right. Is that true? Tell your neighbor the other set of inverses. The other set of inverses. Has someone? Aria? Davina? X squared, and what's its inverse? Square root. That is correct. And today we're going to be focusing on those fours. That's why, I don't know if you guys noticed, in the past we did a lot of work with inverses. And for the past week, I've been giving you inverse practice on the warm-ups. Thank you, Mr. Q. You're welcome. Copy that on your Cornell notes. Example 1, identify the inverse of the function, check, and graph. Identify the inverse of the function, check, and graph. And the function given is f of x equals x squared. We're going to do this one together on Cornell notes, and then from there we're going to go to the graph so we can see what they're trying to show us. Okay, let me zoom in. All right, bless you. By now you should be able to find me the inverse because you've been practicing this for 2 weeks on the warm-ups. Is that correct? Very good. But just for the sake of this, I'm going to do this one together with you. In color, I'm going to change f of x to y. From there, I need to solve for x. So how do I cancel that square? Square root, whatever I do to one side, I do to the other. I'm left with square root of y equals to x because the square root cancels the square. Next, I need to exchange the variables. Move the x over here and the y over there. That becomes square root of x equals y. That's what we call it, inverse. And lastly, we cannot leave it written equal to y. What do we write here? F inverse of x, and all that equal to square root of x. Label is inverse. You're like, Mr. Q, this is exactly what I got. I've been practicing this on the warm-ups. Good. Go to the funner part, yeah? Right next to it, draw a line down, and we're going to check to see if it's inverse. What does that mean, Mr. Q? What it means is that if one is the inverse of the other, that means we get rid of all the operations, and at the end we have to end up with the variable what? X by itself. Bless you. So here goes the process. Stay focused, because some of you struggled with this on the first quarter when we covered inverses and checking the inverse. We only did it with linear. Now we're doing it with quadratic and cubic. Here we go. I'm going to start with my first function, f of x equals x squared. The very next step, I'm going to rewrite this, but without the x. So instead of x, I put parentheses. You guys notice I'm missing the x from here and the x from here, yeah? So what am I going to write in there, Mr. Q? Well, if we're checking to see if this is an inverse of that, then I'm going to substitute instead of the x, I'm going to write f inverse of x. So if that's true, this was the rule for this one, but what is the rule for the inverse? What was the rule for the inverse? Square root of x, so that goes right here, square root of x. So let's see, I end up with f of f inverse of x equals 2, let's see. Wait a minute, doesn't the square cancel the square root? Yes, and we're left with, yep, that one is the inverse. What? All right, so we already checked that this is the inverse of that, but now we need to check what? That is the inverse of this one. So now I'm going to write the inverse. I'm going to write f inverse of x equals to square root of x. So for the second step, I write f inverse of parentheses square root of parentheses. What goes in there? What do I write in here, guys? F of x, that is correct. F of x. What was the rule for f of x? X squared, so that goes in here, x squared. So that leaves me with f of inverse of f of x equals 2. Let's see, doesn't the square root cancel the square? And we're left with x. There it is. And now we checked it both ways. Is it its inverse? Yes, because we just proved it there by getting the identity, which is the variable by itself. All right, get your graph paper in front of you. Let's graph this. On the top left of your graph paper, I'm going to write f of x equals x squared, but I'm going to do that in blue. F of x equals x squared on the top left of your graph paper. And then in red, I'm going to write f of inverse of x equals square root of x. I'm going to graph those two. And by now we've had plenty of practice graphing these, so we don't need a table. We can actually just think of an x value, substitute, and get a y value out. Is that correct? So I'm going to do blue first. What is the easiest number we substitute in for x? 0. What is 0 squared? 0, so it's 0, 0. There it is. What would be my next x value? 1. What is 1 squared? So my next point is 1, 1. Next value. 2. What is 2 squared? 4. That goes right there. Now let's go to the negative side. What is negative 1 squared? 1. Negative 2 squared? 4. All right, let's graph our parabola. There it is. All right, so we're done with this one. Let's graph the other one. We have plenty of practice with it this week, yes? All right, so starting with red, what is my first easy value? 0. Square root of 0? 0. What would be the next one? 1, 1, that is correct. What is the next x value that we can get a square root? 4. That gives us 2. And those are the 3 that we always use, is that correct? And so on and so forth. You're saying, I kind of see that it's an inverse of it by looking at the graph, but not totally convinced. Okay, look up, guys. Well, the red function is an inverse of the blue, but only for a portion. Who sees the portion? You guys see it? Okay, if you don't see it, let me do the blue one again. 0, 0, 1, 1. So here's my parabola. Here's my red one. Now, the red and the blue reflect one to the other, not about the x-axis or the y-axis, but it reflects about the y equals x. Like what? Y equals x. Y equals x is right here. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, this way. So if this is our mirror, y equals x, you see now it's reflecting going that way. You see it? Okay. However, does it reflect completely the red one to the blue one? No. It only reflects a certain portion of it. So that portion, I'm going to ask you to give me the domain of the only part that makes these inverses. How could we ever let them know what values of x do you see are obviously inverse one from the other? What obvious x values make the red one inverse from the blue one? How could we know this? Domain. All right. Victor. From what x values are both of them reflecting one another? From 0 to where? And then? And to infinity. From 0 to infinity. So how can I write that? The domain is solution set of x such that x is what? Greater than or equal to? What? 0. Because it starts at 0 and it continues to infinity. You guys see that? So from 0 here, we see that this reflects over here. How about the negatives? Do we include the negatives? Does the red one reflect on the blue one on the negative side? No. What does that mean? That we don't even need this section of that parabola because that's not part of the inverse. Only what? This. This is what we call a restriction. Inverses, some of them are going to have restrictions. You need to state the restriction as a domain. So this tells us that from here and on, they're going to be a inverse one from another. But we cannot do that before that because This doesn't reflect down here. All right, copy this next one, please. Example 1 cube. Some of you are looking at me like, Mr. Q, I needed more warm-up practices. I know, right? Example 1 cube. F of x equals cube root of x. All right? Now that I helped you with one, you should be able to do this one by yourself, right? Find me the inverse. I'll give you some time. Copy that and go. And then I'll help you with the check. All right, let's see. First thing, you change it to y equals to cube root of x. I use blue for that. From there, what cancels a cube root? Cubit. Cubit. I end up with y cubed equals to x, because the cube root cancels the cube. What's the next step? Exchange the variables, the x for the y. We end up with x cubed equals to y. Can we leave it as equal to y? No, that's why we write f inverse of x equals to x cubed, and this is our inverse. And we're like, Mr. Q, this is a piece of cake. We've been doing this for 2 weeks on the warm-ups. I know, right? All right, let's do the check. See how you did with a check. Check. I write my original one, f of x equals cube root of x. But for the next step, we need to substitute for x. So I write f of parentheses cube root of parentheses. What goes inside the parentheses? F inverse of x. And what was the rule? X cubed. That goes right third. F of inverse of x equals 2. This cancels this, and we're left with x. All right. So now that I'm done starting with the regular function, now I'm going to start with the inverse function. F inverse of x equals x cubed. For the next step, we do f inverse of open parentheses for the variables. Cubed. What goes inside the parentheses, guys? F of x. And what was the rule for f of x? Cube root of x. All right, so we end up with f inverse of f of x. And this cancels this. We're left with x. Too easy. Too easy. My goodness. This reminds me of, I don't know, our times tables, right? So you're like, I don't even know this. Can you believe some of you don't know how to do your division or... Anyways. All right, let's go to the graph. Once again, in blue, I'm going to graph f of x equals cube root of x. And in red, I'm going to do the inverse of x, which is x cubed. All right, let's see. Let's graph cube root of x. So you can get me started. What's the first value? 0, 0. And then 1, 1. Okay, and then 8, 2. That is correct. And then negative 1, 1. I'm sorry, negative 1, negative 1. And then negative 8, negative 2. That is correct. You're like, Mr. Q, come on now. These last night, they're a piece of cake. Yeah, good thing you did your practice, huh? All right, let's go to x cubed in red. First value, 0, 0. Okay. If I substitute 1 in there, what is 1 cubed? 1. Next value, if I substitute 2, what is 2 cubed? 8. Let me go the other side. If I substitute negative 1 cubed, negative 1. If I substitute negative 2 cubed, negative 8. Look at that. Question. Are there any restrictions for those inverses? No, it looks like it's going to reflect in opposite directions for both. Is that correct? So if there are no restrictions, tell your neighbor the domain for those inverses. Solution set of x. What? Who's got it? All real numbers. Let's go Roman McGuire. X equals all real numbers. That is correct. You know what? Extra credit. Boom. Just like that. Everywhere. Oh, I should have answered. You should have. Could have, would have. Should have. Oh, there. All right. Show me your parents. Welcome to your with these. Yeah, 4 or 5. Yeah, we just need practice. All right. And the rest is pretty much the same, just changing them to their inverses. Look at that one. First thing we change to y, and then we do what? Square each side, and then at the end, subtract 3, and so on and so forth. But where I want to get to is this one. Copy this one, example 2. Oh, yes. F of x equals 0.2 x squared. 0.2 x squared. Here we go. First step. Change it equal to y. Okay. 0.2 x squared. Now check this out. The next step for the ones we just did right now should have been what? Square root. Is that correct? But that's if we had an invisible 1 here. What can I do to point 2 to make this an invisible 1? Tell your neighbor. What can I do to point 2 to make it an invisible 1? Who's got it? Noah. Divided by itself or multiply by 5. No extra credit. How about that? Times 5 times 5. So we get 5y equals 1x squared. That is correct. And the rest is a piece of cake. Yes? What do we do next? How do we cancel the square? Square root. Square root. This cancels that. We're left with square root of 5y equals to x. What do we do next? Exchange the variables. So we end up with square root of 5x equals y. Can we do it like that? No, we rewrite it as square root of 5x equals f inverse of x. And you know how to do the checks and all that, yes? All right, let's do the check. And make sure you write inverse so that you make it obvious. Inverse. Check. So we write f of x equals 0.2 x squared. F of parentheses equals 0.2 times parentheses squared. What goes inside the parentheses, everyone? F of inverse of x. What was the rule for the inverse of x? Square root of 5x. That goes in here. Square root of 5x. All right. Let's see. F of f inverse of x equals 2. Let's see. The squared cancels the square root, doesn't it? Yes, this cancels that. So we're left with 0.2 times 5x, so that's what? 1x. Let's go. And you know what to do for the inverse, yeah? Check the inverse by doing f of inverse of x equals square root of 5x. F of inverse of parentheses equals square root of 5 times parentheses. And what goes in the parentheses? F of x, which was the rule of 0.2x squared. And so on and so forth. Yeah. All right, so for home plate tonight, pages 488, 489 only. There is tutoring today. If I don't see you, enjoy your home plate, or stop and say hey. By the way, and by the way, it's free. Good one, guys. See you guys tomorrow. Bye.